So the first time, a couple months ago, we started talking about very high-level concepts about Kubernetes and choices you'd make in your org before you start using Kubernetes as your deployment target. We talked about how your company structure, your app architecture, and even some technical aspects of your landscape can influence where you deploy to Kubernetes and even the run the whole Kubernetes driven landscape. After that, Matt Casperson talked a lot about how you can actually provision Kubernetes, bootstrap the clusters, and automate the whole project rollout with Octopus, and even do maintenance with our runbooks. How you can easily, without exiting the cluster, scale up, scale down infrastructure, and do some debugging or issue investigation for apps deployed on Kubernetes. And today here, we'll talk very simple, practical uh, advice on how you can actually use Octopus and what options you have in Octopus to do the basic thing, basically moving your configuration from place you store it to Kubernetes, the actual deployment. So, but let's start with intros, who we actually are. Uh, can you switch to the next slide, Nick? So, Nick, you go first.
Hi, I'm Nick. I'm a senior engineering manager here at Octopus. I've been here for quite a while and I'm quite excited to be getting more involved in this space going forward. Kit?
And I'm Kit. I'm a product manager. I work with Nick in the same team. And for the last year and a half, we work on Kubernetes or deployments to Kubernetes. So why should you care listening to us? Well, because for the last year we talked to about like 100 customers, and we got their feedback on the real case scenarios, starting from very small niche deployments to Kubernetes, where they maybe deploy just one app, to massive at scale, hundreds of apps, dozens of teams, hundreds of clusters, and we spotted like same uh, themes all over the place. So same issues and same questions. So through these three talks, we're trying to answer them. Okay, so what do you learn here for the next 30 minutes? The main thing you learn is what options you have with Octopus in Kubernetes for Kubernetes. So how you can actually configure that. We'll show you some screens, we'll show you some examples, we'll explain some hidden features which you can use in Octopus and greatly benefit from. Who would benefit from this talk? Well, mostly it's for DevOps engineers, software engineers, platform engineers who actually build and manage deployment pipelines. You would also benefit from this if you don't build them yourself, but just use Octopus to deploy to Kubernetes, because that some concepts will probably be a bit more straightforward for you. And finally, if you just starting with Kubernetes, or maybe you have some mid-level experience with Kubernetes, this talk definitely will be useful. Okay, let's jump to the agenda, how we'll structure the conversation today. So we'll start with basic concepts. We talk about like what it means actually deployment to Kubernetes and deployment configuration and what we recommend. We have our very opinionated view here. Then we talk about progressive scenarios. We'll start with a very simple thing. What if I just want to deploy one app and I want to progress this app through a couple environments and tenants? Then we talk about most complicated scenario. What if I have now multiple apps and I want to centralize pipeline management for them? And finally, what I want to maybe help some other team member or another team set up the Kubernetes deployments easier from the pre-configured template, so we can streamline the process and reduce unnecessary steps in operation. And then, starting from point 5 and onwards, we'll talk about specific steps we have in Octopus, how they work, and we'll show some examples. All right, so let's start with what is deployment to Kubernetes is. Doesn't matter which tool you use, and actually doesn't matter what step in Octopus you use, deployment to Kubernetes always starts with configuration. So, the big difference between more classical targets and VMs comes to mind first. Kubernetes is declarative, as you know, and in Kubernetes we must have definition, like configuration, for each resource we deploy. Otherwise, nothing happens. So you have to start the configuration anyway. But when you start reading about Kubernetes, you find that there are actually a few different ways to do that, a few different best practice or recommended methods how you define the configuration. The popular one nowadays is to have configuration as a source of truth for each environment or target or tenant. Basically, if you have, let's say, 5 clusters, 5 environments, you'll probably have 5 configurations. So we're actually suggesting today a very opinionated approach, and we believe you actually shouldn't do that. So our first recommendation as to use Octopus for Kubernetes deployments is simplify and have just one configuration. Choose at least one configuration per app, and don't store a separate version of it for each environment and tenant. We'll show how you can do that. But even more, think about that. Maybe later you want to consider one configuration for a few apps or maybe for your whole set of microservices. The second concept which we want to introduce early, and again, we'll show you how to do it in the real scenario, is don't update your version of configuration every time you want to release a new version of your software. Again, there are 2 schools of thoughts. You can find information that actually you need to update the version every time you release a new container. And we know, like with Kubernetes, every time we release new software, we're talking about the new container tag. So some methods would suggest just commit the new version, change this tag for a container every time, and have a version of the configuration file. It can work, but it introduces a lot of extra steps on your CI part, and it actually creates this bond because your CI before that would produce just container, and that container might be used across as many targets as you want. Here, your CI must produce an actual artifact which is specific to a certain environment. And then if you want to progress it through multiple environments, you have to deal with that. You have to maybe recommit or orchestrate your progression of the CI part. It's laborious, and we believe we can do a bit of a better job here. All right, let's say you agree with the first 2 points. Now, I would ask you a few questions, and I think this you should consider before you start configuring Octopus. So first of all, at some point you need to store your configuration somewhere. Where would you like to store configuration? We have 2 options, and choose the one which is right for you. Both work with Octopus. The first and most obvious one, configuration as code. Git is a great place to edit the code, evolve it, and have a version of it. And you can just start using Git and store configuration there. The second option, which is not that obvious but also works in many scenarios, is you can store it right in Octopus. And we'll show you how to do that. It has some advantages. It's simple start, one less tool, and it really works for simple deployments. Second question is, will you deploy only with Octopus? And the answer in many cases would be yes. Why not? But in some scenarios, like for example, developers might want to run the local tests on their laptop and they maybe have a small version of the cluster on the laptop. In this case, they might want to use some extra tool or just manual deployment to quickly test the code. So basically, will you reuse this configuration for both local tests and deployment through the environments? If yes, we'll show you how you can do that. And finally, well, do you need to manage some variables outside of Octopus? As we mentioned at the beginning, we suggest you use one configuration at least per application. So to adapt this configuration per environment and tenant, you might need some variables. And also, you will probably use variables for secrets, for some environment parameters, and for many other things. So will you want to store all of them in Octopus or not? That's a question, and we'll show you both scenarios. Why might you not want to store them in Octopus? Well, there are a few options. For example, your company might use something like a Cloud Vault or HashiCorp Vault And it might be just a company policy to store and manage some variables there. And totally fine. We can work with that. You might want just to store some variables which you don't change often, as just hard code them in configuration and put them in Git. Please don't do it with secrets. It's a bad idea. But for everything else, that just can work. And in some other scenarios, maybe you have, let's say, the same variable which you use for your deployment, but also infrastructure provisioning, and maybe some other tools, and then storing that in the third place just makes a lot of sense because it will be used multiple times. All right, so let's say you answered these three questions, you have them in mind, and then we can jump into the first very simple scenario. The first scenario would be, what if I have just one app which I want to deploy to a Kubernetes cluster? Let's say we're just trying out, we have a first app which you want to build and deploy. In this case, it's very straightforward. No need to think about any complicated concepts. What you want to do, you just want to have one configuration for this app, and you want to deploy it progressively through a couple of environments. Let's say you're dealing with like test, dev, stage, and production. In this case, the first question I would ask is, what is different about these environments? So think about this. What should be different between, let's say, staging and production? And if there is something like number of replicas, maybe labels, maybe resource constraints, just scope it and put it all into Octopus variables. Think about this. Everything which is not changing from environment to environment, you can store in the configuration file. I mean, you can put it in variable, but it won't give you much value. But everything which is changing, just put it in the Octopus variable and use a project variable for this. Then the second question is there something which should be consistent for release, but would be updated with each release? And yes, the obvious answer for this is it's at least a container tag. So again, don't put it in the configuration file, don't hard code it. We'll show you how to deal with that. So, and yeah, maybe at this stage, Nick, let's switch to them or just show how you can do the variable and the container reference in Octopus. And then we'll talk about three other things on the slide.
That's right. All right. Bear with us as we switch around to lots of different places inside of our different configuration to show off different features. It's a bit tricky to get them all all in one sort of setup. So yeah, as Kit was explaining, a common pattern you'd want to follow in scoping, variables that change based on your environments would be something that would be security or access related. So the accounts here is an example of that for this particular project. And then there's a wide variety of other variables that you'd want to scope and have that change per environment.
Yeah, so basically the concept here is just create it first for your first environment and then just add different values and change the scoping. That's very straightforward. Can you also show can you just open a raw YAML and show the container reference?
Great question.
Basically, what we're talking about here is Octopus can just source YAML files from Git, for example. And then in the configuration, you can put container image and tag, which requires you to update this just one parameter every time you want to deploy a new version. It's laborious. As I said before, it will be on your sidebar. What we can do in Octopus, though, in Octopus, you can just link your container repository, container registry, to the Octopus step. And every time you create a new release, Octopus will look at the container, find the new tag, and use it, replace it as a variable in the YAML configuration. So if you do that, basically define the configuration once, and then every time you release a new version of the container, Octopus just replace it for you and snapshot it when you create release, right? So doing this, you can update this file, the configuration file, only when you actually want to change the configuration itself, not any reason you container version. That just saves a lot of time. All right, let's move on. I mentioned that if you have one project, you might want to deploy, you might promote your app through multiple environments. And then it makes a lot of sense, it makes it easy. Um, but what if you want to uh, promote it through, I mean, it's kind of not that hard, right? It's easy in a way that if I just have a couple environments, why would I benefit from using Octopus? I can just use a bunch of branches or folders, and why would I use variables to template my configuration? But if you want, what if you want to deploy to, let's say, 300 different environments, and you want to have 300 versions of your app? That's actually a real case example, and that's why we have tenants. So, Nick, over to you. Just let's talk about tenants for a little bit.
Thanks. Great segue to tenants. Okay. Uh, tenants is a very powerful feature of Octopus Deploy. Let me show you one we've prepared earlier. This year we've had another team focused on ensuring great performance of the UI around multiple tenants, in the scale of hundreds for customers, to ensure that they have smooth filtering and loading. So if you can keep up with my scrolling here, this is a single project that can be deployed to up to however many 100+ tenants we have here. And this is the sort of the dashboard view experience you have of this, to be able to filter down and have this large, large sort of sweeping view of where a single application in this case, or a project that could represent multiple applications, how that is rolling out to different environments, and not just to different environments, but the environment and tenant combinations. So as it rolls out through dev, staging, production, or however you name your environment, for all your different customers, the tenants representing those.
Yeah, so what is the real use case here? And we promised to tell you about deploying to Kubernetes at scale. So this is where this one configuration variable is really shining. So imagine this. I have my app and I want to deploy it to my dev and production. But at some point, let's say my production is in a cloud. At some point, my company grow and I have more customers across the globe. And now I want to have just a few versions of this production. Let's say I have multiple regions, might be a region in Oceania, in North America, in Europe. And at this case, I have already 3 production environments. And although they're all production, it still might be 3 different targets. And I might change, let's say, labels or resource constraints, depending on the region. And maybe later, we have we're starting to serve very big customers and we want to have an isolated version of the app for them. So now we're running we provision a cluster per each customer. And what if we have 200 of this? So this is where tenants really work. And this is where you definitely want to have 200 branches or 200 folders, and just having one variable with maybe even like 50 or 100 different values definitely works way better. But let's move one step further. What if you are not just deploying one app across 300 targets? What if now you moved to microservice architecture? What if you're now deploying a few hundred apps to a few hundred targets? In this case, you might not want at this point to have 300 configuration, especially if it's microservices, and your microservices are probably quite similar. Let's say you have like just 100 of backend API services running. It just what's different about them? Probably not so much. Probably just a container name and tag, and everything else very likely would be the same. So what to do in this case? So in this case, in Octopus, we suggest just using the same configuration, basically converting your configuration for a project into configuration template. Basically, use your set of YAMLs across multiple projects, doing the same thing you did for environment. But in this case, you'll just have to replace more properties. If before you were maybe changing your container tag with every release, and maybe number of replicas per environment, here you might also considering changing labels to reflect the app you're deploying to. Maybe you will change the namespace, and most likely you will change the container image, right? So, but except for that, the concept still stands. You have one source of truth, one configuration template, you have a bunch of variables, and now you just change them per project and environment and tenant, not just per environment and tenant. So for this advanced scenario, we also have a couple of features Octopus. So the first one to mention is variable sets. So variable sets, it's a set of variables which exist outside of a project and could be used by multiple projects. So in this case, if you want to deploy 10 apps with the same configuration template, you can create a variable set for them and just use the variable set, just reference this in all 10 projects you want to use. Easy. In this case, you just reuse the same values, for example, across all the environments. The second feature which we might use in Octopus is system variables. And this is a very powerful one, so we'll talk about this a bit later in a second. And the third one, which I think also we can show, Nick, is how you can use the dashboard to actually observe either progression for one app across environments or progression of all your apps across all the environments. It's kind of one-on-one, but let's still take a look. Yeah, so this is it. So imagine how useful it is if you have like a lot of microservices. Yeah. Okay, but now let's talk about the real powerful stuff. Let's talk about system variables and why it's important if you template across multiple apps. Over to you, Nick.
Thanks. Yes, system variables are an example of one of my favorite things that's really easy to use and get right into the depths of your application where you need it. So the simplest example that I have is just getting a hold of the Git branch name, the commit, the ref, and the build number, and surfacing that up in your applications, especially in the case where you're deploying the same application to a variety of different environments. You're continuously deploying, so it's always changing. When people are testing and reporting bugs, this way you'll guarantee that the where they're reporting the issue is accurate, like down to the commit, the version, and there's no confusion that they're on the wrong environment and reporting something that has already been fixed. Like, it's always a waste of time, people chasing around a bug or an issue, but it's already been reported and it's already been fixed. So flowing system variables through can really help with that. The next
And there are,
thing.
wait a second. There are also other examples how they can be useful. So think about this. What if I have one configuration I want to use across multiple projects? In this case, you would still have to change, let's say you have a variable for your container image. You still need to define this variable and change it across every project. You have 50 projects, you need to have 50 values because your container should be different, right? And same maybe about names, true for namespace, and same might be true for some labels. But if you just use some naming rules, naming convention, Octopus, you can just use Octopus variable because Octopus can substitute and use, for example, a project name as a variable value or environment as a variable value. So from here, instead of just changing your container name for each application, you can just say, okay, what if I name my project exactly as I name my container? Wouldn't that be easy? Yep, you just don't need to change. It's just one less parameter to change. And what if you do the same with labels and namespaces? Basically, we saw examples that people can just define configuration once and there will be no changes whatsoever if you reuse this configuration across 50 or 100 of projects. That's convenient, and that's the power of system variables. Finally, let's advance our scenario even more, like the last level. So what if it's not just you? Yeah, let's go to the next slide. What if it's not just you who deploying 50 apps across like 300 environments? What if you have actually a couple of teams you're working with? And what if you want to help these teams to build new pipelines for new apps, for new microservices to introduce? Well, you might just teach them all that. You might explain them how Octopus works and how to create and manage variable sets and variables and system variables. And you also need to teach them how to run and change YAML files. But instead of that, you can just wrap everything we just discussed in a simple step template. And step template can allow you to surface just a couple of things, couple of parameters you want to change, hiding all the complexity behind the scenes. And then you can just advise your team members, just, hey guys, whatever you want to create in deployment to Octopus, just choose this template, add it to your project, save it, fill in a couple of values, and hit deploy button, and that will work. And if you did everything we mentioned before, like, for example, system variables, you can just surface a few things like environment variables for your app and maybe a few other parameters and nothing else. They will have to change nothing else. So this is just a way to really scale it and empower other people who might not have the same knowledge about Octopus and Kubernetes. Just empower them to build simple deployment projects. Yep. Okay. I just want to briefly mention a few other features quickly, so which can make your life even easier with Kubernetes. So one of them is Kubernetes object status. So if we can show it basically from this here, you can just see the deployment status in Octopus. Octopus now knows about the application deployed and can show you the status of each deployed resource. It's good for debugging because you can open and see like if that's what you meant and if any of the resources failed. But it's actually better, even better if you do it in automated mode. So basically this view gives you an idea of if the cluster achieved desired state. And so you can trigger some behavior in Octopus. For example, if the step failed, if the desired state didn't achieve, you can redeploy, you can send a message, you can do something else. So basically, this just gives you a confirmation of deployment success or failure. And from here, using this feature, you can build, for example, auto promotion, configure auto promotion lifecycle. You can say always deploy to test, and if test configuration test deployment was successful, immediately deploy to stage. So you can build scenarios like this using combining lifecycle and Kubernetes object status. And Kubernetes object status is on by default. So basically, if you add a new step, a new building step for Kubernetes and Octopus, this feature will just work for you. So just take a look if you haven't discovered it yet and see how it can be helpful. Okay, from here, let's do even more practical stuff. Let's talk about how many we want to cover. 5 built-in steps. We have an Octopus, which you can use for Kubernetes deployments. We'll talk about plus and minuses, when and why you might choose each of them, and how you may progress as complexity deployment grow. Okay, Nick, over to you. Why do we have a UI step?
Great question. The UI step is probably the easiest way to get started with Octopus and your Kubernetes sort of deployments. So you were talking earlier, and we talked earlier about how the step templates help wrap complexity, and so your deployment teams can focus on building the applications, stay in their domain where it matters. But at some point, someone has to build up the expertise of how you're going to configure and deploy your system specific to how you want to run Kubernetes. So maybe now let's put on our sort of platform team engineer um, and pick one of these steps and sort of walk through about all the options that are available for building the step. So it will basically guide you through and supports a lot of the standard, simpler things you want to do at first. Picking where you're sourcing your YAML, the resource types, where it's going to deploy, managing the replicas, adding labels. This is where you can also get the benefits of just, one-click blue-green deployment. You set this up and it will just guide you through and configure it. So this is a great way to get started and as you explore the process. But the limitations of this is, as you see, we're still scrolling. Even though a lot of the options are here, it just cannot contain everything. So its limitations will be the more advanced settings, different combinations. But really, this doesn't scale. So you're using Kubernetes to deploy a large set of things from a large set of teams. You'll only be wanting to go through the UI as you're exploring and something new, as you're setting up, as you're testing it. But once it's all configured and happy, you're going to want to use the more advanced capabilities inside Octopus and the other sort of open source tooling out there, because you want your deployment to scale. You want your deployment process and your techniques around deploying and releasing your software to scale as well. So I think that's the right time to jump. Oh yeah, go on, Kit.
Just sum it up on this one. So when do we want to use the UI step? Well, if you don't really want to do with YAML, it's a way to start with UI. In this case, you will store all configuration in Octopus. That's this case we mentioned at the beginning, that you don't want to use external Git or any other way to source, or like, I don't know, Helm chart, a repository, something like this. So everything is in Octopus, and it could be actually versioned with configures code. And yes, if you want just out of the box blue-green without any manual configuration, this is the one you might use. Can you scale this UI step? Yes, you can. You can use it across multiple projects. You can use it across microservices. When you can't really scale it, is then you want something which UI doesn't cover. Some extra resources or unique parameters, or something where UI just, it's really big. We didn't want to make it even bigger. So if you want something more than that, you might think about the next option. And next option is complete opposite. So here we had a heavy UI with a lot of capabilities. The next one, the UI is really simple, but we expect you storing everything as code in one of the options. Over to you, Nick. How can we do
Yes,
that?
thank you. Yes, the easiest and the most common is the Git repository. So you can migrate your UI build step into Git and then expand on it there, or you can package them up if you're sourcing it from multiple Git repositories. The inline YAML option here is still for the simpler case, but where you just want to get the right snippet of YAML in the right places as you're deploying. We'll come back and demo some of this as it forms part of covering how we do sort of the next level of advanced YAML configuration, which is taking advantage of Kustomize. So before you move to Kustomize, you will have gotten used to using all the features inside Octopus, or realize that you want to replace larger chunks of YAML. So the variable substitution, they were all great for single changes. But as Kit was explaining, as you want to sort of empower your teams to reuse the great knowledge and sort of the the path that's being taken by the rest of your engineers in the organization to develop, sort of common standard patterns for deploying your containers, you want to consider using Kustomize at this point, where you can leverage changing out large chunks and sort of reusing standard approaches of, okay, this is how we configure a load balancer. This is how we configure something else. I'm drawing a blank there, Kit, as we configure other standard components that we're going to deploy into the cluster.
Yep, that's it true. And the power of Kustomize as you combine locus variables is you can actually think about Kustomize as a way to build powerful templates for multiple apps. We mentioned before that you might have 10 or 15 backend microservices, which with a very similar configuration. But what if you have actually 15 microservices, API microservices in your backend, but also a few different databases, but also front end? These apps will have different block stack configuration. For databases, you might want to use stateful sets instead of deployments, and you might need to provision volumes. For front-end apps, you might want to use ingress. So what's the way to actually add or remove or replace such big blocks of YAML? Well, Kustomize can do it for you. So if you can imagine this, just having very simple base layer and then adding like an onion, you can add one layer to specify your unique app parameters. Let's say this layer will fork and add volume for databases and ingress for your front-end apps. And then the second layer would specify change, for example, labels, namespaces, and resources for different environments. So this way you can just model, your model will be way more powerful. And finally, we mentioned at the very beginning, what if your developers actually want to still use this configuration and deploy it to their laptops, just to do some ad hoc testing? So if you just use raw YAML and Octopus variables, this YAML using this, for example, deploying with kubectl won't really work, because as soon as you add the variable, other tools don't recognize it. It will be invalid YAML. But with Kustomize, you simply do it. You can have absolutely valid base for your Kustomize, which you can deploy with any tool. And then Octopus variables could be introduced with overlays. So this is actually the way to achieve these deployments with multiple tools. So this is a couple scenarios that Kustomize is useful. But again, you can always just use it for one app and environments if you do want to change YAML blocks for your environment progression. It's also valid. Okay, now let's talk about yet another step, the Helm.
Yeah, the Helm step's an even simpler one to use. This is where you want to just leverage the the great efforts of others packaging up their your third-party application. So this is an easy way to just get your coordination and deployments happening inside Octopus, combined with the rest of your projects, but all the heavy lifting is done by the package authors. So some good examples here are the combinations of, say, Prometheus and Grafana for your logging. So those you would just simply add the package library into Helm, get the suitable packages, and deploy them into the clusters that you sort of where you need them to go. And that way you're reusing the authentication and just the secrets that are either stored in Octopus or that Octopus is sort of wired in to use. And a powerful sort of safety net here is using the flags that come from the Helm process that are part of Helm charts, and that's the atomic keyword, so you can get the rollback, the safe rollback if there's a failed upgrade.
Yeah, and
Kit, was there anything more to add for Helm?
Or maybe you just love Helm. It's also fine. Customize the Helm to extend competing ways to template Kubernetes, although a bit different. And if you just use Helm for maybe years and you just love documentation, you can use it with Octopus and benefit from the whole ecosystem. And you know what? We also have a Helm chat for Octopus itself, so you can actually deploy Octopus with Octopus and Helm. So yeah. And finally, probably the most like unleashed, the most powerful, but also the most complicated way to deploy Kubernetes is just using scripts. Nick, why would we use scripts as we have like so many great building steps?
That's right. Sometimes the just dropping down to something very simple is just the easiest approach. So this one just lets you run, runs whatever commands you like straight against the container. So you get the safety and auditing of Octopus. So you get to control who can run these commands against the clusters. So you may want to well, the good example we have is of a maintenance task, the simplest one. So in your developer and testing environments, it would make sense to gain the cost savings of scaling down pods to zero at the end of a business day and scaling them back up. That's something you wouldn't want someone to be able to run against production. So with the permission system inside Octopus, you can have these set up to be runnable by anyone in your organization against your pre-production environment, and basically not allowed to be run against production. Let's say it was a scaling one, but if there was smoke tests and maintenance ones, those you would allow or would be part of your process. So I was going to quickly show a run book that's got this, just so we can see how straightforward it is. So yeah, run books is the simplest way to run these. So if we look at a single run book with a single step, scale pods to zero, its inline source code is here. There's the command kubectl. There's the action scale replicas down to zero, and combined with sort of variable substitution based on the what's actually being scaled down. In this case, the deployment. Yeah, and it's also when you need something unique or any other kind of ad hoc task.
Yep, so we commonly see the step used with runbooks as a maintenance, and you don't need to provide access to the cluster in this case. But yeah, you can think about other applications too. Basically, what this script does, the step does, it just gives you Kubernetes cluster context. So every time you execute kubectl command in the script, you don't need to authenticate with the cluster. Octopus does it for you. Except for that, you have total freedom and you can do basically, you can run any code. After all, it's a script. So let's recap. We talked about how to scale deployments to Kubernetes with Octopus. And we said that we have two main pillars of our Kubernetes approach. The first one is use one configuration for the app, at least, and sometimes use one configuration for multiple apps. That will save you a lot of time and struggle. And Octopus can do that. Everything else can give you the power to alternate this configuration to adapt it for environment, tenant, or even different app type. We mentioned that you can start simple and then make scenario more complicated, use features like variable sets, system variable, and automate environment progression with Octopus. We covered 5 steps and showed you how you can just use UI to configure deployment Kubernetes, how you can use plain YAML files, and up to building very complex scenarios to customize, or using ready to deploy Helm packages. So all that is possible with Octopus. Yeah, and that's about it. I think we should stop here. And we just one thing to add, we really like to hear feedback on this. So please, if you want to share some of your experience with how you use Octopus for Kubernetes, or maybe where you struggle, just don't hesitate. Please contact our team and let's have a chat about it. Thank you.
Awesome. Thank you very much. Great session. And again, if you guys have any questions about this, feel free to reach out to either Kit or to Nick. And as always, please take some time to register for our upcoming webinars. As I looking at the calendar here, we've got a pretty full calendar right up until next year. So anyways, Nick, Kit, thank you very much for your informative session, and thank you for your time and attention joining us here on today's webinar. We will see you on the next one.